Hey guys, welcome. Mr. Moscato with you on yet another snow day. I know you guys love these videos, so here we go. Today what we're going to do is we're going to talk about inverse linear functions. Yeah, zooks. All right, so it's not as scary as it sounds. Inverse linear functions, if you want to follow along, we're on page 263 in the book, chapter 4-7. All right, and so what does that mean? Inverse linear function, all right, or an inverse relation. All right, so we know that when we're dealing with a function, when we're dealing with a graph, right, we have an x, y coordinate for a point on a graph. Um, those values come from an x value that is the input into the equation, and then that gives us a y value, which is the output of the equation, right? So we've been talking about that concept since September. Okay, input and output. X value is input, y value is output. All right, that relationship between the x and the y, okay, is how we're able to draw the graph, right? So we have an x with a corresponding y value. We plot the point, we connect the dots, all right, and that gives us the picture of the graph. All right. Well, an inverse relation is when we take the x value and the y value and we switch them. All right. So what happens is that, let's say that we have a point 6 comma 10, right? So my x value is 6 and the y value is 10. Well, an inverse relation, all right, if we were creating an inverse situation, we would take the y value and make it the x value, and take the x value and make it the y value. All right, so the inverse of that point at 6 comma 10 would be a point at 10 comma 6. All right, so why do we do this? All right, well, inverse functions basically allow us to reverse the math that we did. For example, let's say that we have a a Fahrenheit to Celsius conversion. All right, and there is a mathematical equation where we put in um, a Fahrenheit value. All right, let's say 60 degrees, and then it does the math happens however it happens, and we get a corresponding value in Celsius. Okay, I don't know what the conversion is. We could look it up, but that's okay. Um, Now, what happens if we want to do a Celsius to Fahrenheit conversion? So, in other words, what happens if we want to reverse it? Okay, well, we would have an inverse graph. Okay, the function that would convert Fahrenheit to Celsius, if we create an inverse function, then we can create a Celsius to Fahrenheit conversion. All right, so that's basically what we're talking about. All right, it's kind of like another thing that we can do is like gas money. Okay, so I put in $25 of gas into my car, and I was able to drive 350 miles. Okay, well, that's fine. All right. But let's say that I wanted to do some kind of a projection. All right. So instead of putting in the dollar value for the amount of gas that I put in and getting back the number of miles that that I drove. All right. Well, what happens if I wanted to do something like, well, let's say that I'm planning a trip, and the entire trip is going to, I'm going to drive 825 miles. How much money in gas is that going to cost? Right. So I can do an inverse function that would then, my input would be my miles and my output would be the dollars. Okay. As opposed to the original equation, which was the input is dollars and the output is the miles. Okay, so that's what we're talking about. So when we talk about inverse functions and inverse linear functions, All right, that's really all we're talking about. Okay, we have one formula that gives us a value based on an input. Well, what if we reversed it? What if we wanted to reverse it? All right, so that's what we're dealing with. All right, so um, give me a second. I'm going to switch over to my iPad, and then we'll get started with some of these concepts. All right? All right. All right, guys, here we go. So we have two graphs. These are from the book. All right, and it tells us to graph the inverse of each relation. All right, so the first thing that we need to do is we need to take a look at our original function, our original linear equation that we have here. And we're going to identify a couple of points. All right, because to graph the inverse, to figure out what the inverse points are, we need to figure out what the original points are, and then we're going to go ahead and graph the inverse. All right, figure out the inverse and then graph it. All right, so let's take a look here. So I have a point here. All right, and this looks like it's my 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 x-intercept. I'm sorry, right? So my x-intercept, all right, is at 2, 0. Okay, and then I have another point here, right? So I'm just looking for good points that I can easily identify. All right, so this point here is at -1, 1, right? And then it looks like I have another point here, okay, and this one is at -4, right? 1, 2, 3, 4, yep, comma 2. Okay, so those are three decent points that I have on my original function, right? So I'm going to write these down here, right? So this is the original, all right, and these are some of the points, all right? So -4, comma 2, all right, -1, comma 1, and 2, comma 0. Okay, good so far. All right, I'm going to just erase these points because we're going to use the same graph in a moment. All right, so now the next thing I'm going to do is I'm going to figure out the inverse relation between for these points, right? So I have the original over here, and then I have the inverse over here. All right, so remember that what we just talked about before, and we said that the inverse function or the inverse relation, all right, of a point is basically we take the x value and the y value and we flip-flop them, all right? So the x value becomes the y value and the y value becomes the x value, all right? So we're going to take a look at this first point, okay? And if I have an x value of -4 and a y value of +2, then my inverse is just the opposite, right? My x value is 2 and my y value is -4. Okay, so the x value becomes the y value and the y value becomes the x value. The input becomes the output and the output becomes the input. Okay, pretty straightforward, right? There's no real magic here. For the second point, all right, we're at -1, 1. We're going to reverse the x and the y, so that means that we're going to be at +1, -1. Okay, again, the x value becomes y, the y value becomes x. All right, it's just that simple. All right, and then the last one, we're at 2, 0, so we will be at 0, 2. All right, real simple. All right, so the next thing then is let's graph our function. Okay, so my inverse function, so I have a point at 2, -4. So x is 2, y is -4, 1, 2, 3, 4. So I'm going to have a point down here. Okay, the next point is at 1, -1. All right, so +1, x, -1, y. Okay, so that's going to be there. And then the last value is going to be at 0, 2. So the inverse function is actually going to have a y-intercept of 2. Okay, so all I need to do now, right, is grab a straight edge and connect the dots. All right, and there is my inverse function. Okay, it's a little squiggly, but my straight edge wasn't that straight. All right, so that's it. All right, that's the inverse of that first graph. Okay, it is that simple. Okay, next. All right, let's take a look at 2b. Right, we're going to do the exact same thing. Identify a couple of points. All right, 2 or 3 points on the original graph, and then we're just going to draw the reverse. Okay, so what do we have here? Right, so we have a point there. Okay, and that's going to be at -4, 1, 2, 3, 4. Yeah, -4 comma 0. Right, so I have an x-intercept of -4. All right, looks like I have another point here. Okay, and that's at -1, +1. -1 comma +1. Okay, and then the last point that we have is, let's say here, right, and that's going to be a 2 comma 2, right, 1 2 1 2. Yep. Okay, I'm going to write these down here. Original, okay, we're at -4 comma 0. Okay, original we are at -1 comma 1, and original we are at 2 comma 2. All right, so my inverse then, I'm going to do it in green again. Okay, my inverse, all right, is I do the exact same thing as I did before. I'm just going to switch the x's and the y's. All right, so my output becomes my input, and my input becomes my output. All right, so this inverse function is going to have a value at, or a point at 0 comma -4. Okay, it's going to have another value at 1 comma -1. Okay, and it's going to have another value at 2 comma 2, right? So those points, right, the input becomes the output becomes the input, but they're the same value, so it's going to be the exact same thing. Okay, let me erase what's on my graph right now, and then we will redraw this. Okay, so the inverse value then is going to be at 0, -4, so 1, 2, 3, 4. So it has a y, the inverse has a y-intercept of -4. 1, 2, 3, 4 is going to be here. It's going to be at another point at +1, -1. So +1, -1 is going to be here. All right, and then it's going to have another value at 2 comma 2, which is going to be there. Okay, let me grab my straight edge, draw my line. Okay, and there is our inverse function, our inverse graph. Okay, and that's basically it. In terms of getting a graph, taking a look at the points and creating the inverse, that's really it, right? Find a couple of the points, 2 or 3 of the points, flip the x's and the y's, okay? Draw those new points on the graph, all right, and then connect the dots. And now you have a picture of the inverse function, okay? Good, easy, right? It sounds really difficult, all right, and you can impress your friends and your parents and whoever else you want to impress, right? And say, oh yes, I'm an expert in inverse linear functions, right? And they will have no idea what you're talking about, all right. But you know, you don't have to really explain it to them. It just sounds impressive, all right. So now, the previous example was, what if I give you the graph and I wanted you to graph the inverse of the function? But now what we're going to take a look at is what happens if I give you the function itself, the equation itself, and I ask you to give me the inverse function, right? The inverse of the equation that I gave you. All right, so the first thing that we need to do is just take a step back and remember a couple of things. All right, so first of all, I have f of x equals 4x minus 12. All right, remember that I can also write this as y equals 4x minus 12, right? There's no difference whether the equation is in function notation, f of x notation, right? Or whether it is in slope-intercept form, y equals 4x minus 12. So f of x equals 4x minus 12 and y equals 4x minus 12 are exactly the same thing, okay? Good so far, right? We've been talking about this. This is nothing new, all right? The next thing that you have to know, all right, is something about inverse function notation, right? So we know that function notation is f of x or g of x or whatever the name of our function is, right? And whatever the name of our input is, right? So it could be g of t or h of l or whatever it is, okay? In this case, it's f of x is the name of the function and x is our input, okay? When we're dealing with an inverse function, the inverse notation, okay, is written as f of negative 1, all right, or f negative 1 x, okay? Now, this negative 1 is not an exponent, okay? Do not confuse that negative 1 on top of the f as an exponent. This is simply saying that this particular function is an inverse, right, function. Good? Yeah? All right, good. All right, that's all that means, okay? That f negative 1 is an inverse function. Good. The next thing that we have to understand, all right, is that to get the inverse function, all right, of an equation, all right, or of another function, what we do is we take the y and we take the x and we switch them, okay? So what we do here is we say, all right, if y equals 4x minus 12, I'm going to take the x and I'm going to switch it with the y, and I'm going to take the y and I'm going to switch it with the x, okay? And then I'm going to solve for y. All right, so to get the inverse, okay, we switch, I'm writing this all out for you, we switch the x and the y, and then we solve for y. All right, so we switch the x and the y, and we solve for y. All right, so what is this going to look like, right? So again, we have y equals, so let's start right from the beginning. Y equals 4x minus 12, okay? I'm going to switch the x and the y, okay? X equals 4y minus 12. Now I'm going to solve for y, okay? What's in the way? Well, I can subtract 4y from both sides, okay? 4y there minus 4y there, right? So I get negative 4y plus x equals negative 12, okay? I'm going to subtract x, all right, from each side, all right? So I'm going to get negative 4y equals negative x minus 12, all right? And then I'm going to divide everything by negative 4. Again, what's in the way? Negative 4 is in the way, so I'm going to divide everything by negative 4. Okay, so I'm going to end up with y equals, right, negative x over negative 4 is basically a positive 1/4 x, okay, and then a negative 12 divided by negative 4 is a positive 3. All right, so my inverse function, all right, of y equals 4x minus 12 is y equals 1/4 x plus 3, okay? This is the inverse, all right? So when I write this, okay, I would write this, all right? F negative 1 of x equals 1/4 x plus 3, okay? Pretty straightforward, all right? So the only real trick here, right, is that we take the x and we take the y and we switch it and then we solve for y. All right, we're going to try one more. We're going to try this one. F of x equals 1/3 x plus 7. Let me just switch the page here. F of x equals 1/3 x, what did I say, plus 7. Okay, I'm going to rewrite it in just y-intercept form. Y equals 1/3 x plus 7. I'm going to switch the x and the y. x equals 1/3 y plus 7. Okay, and then I'm going to solve for y. Okay, so I'm going to do this one a little bit different. I'm actually going to end up with the y over on the right and the equation over on the left. It's the exact same thing. All right, so I'm going to subtract 7 here, x minus 7, okay, equals 1/3 y. Okay, I can multiply both sides by 3 to get rid of the 1/3. Okay, so this is going to give me 3x minus 21, okay, equals y. All right, so let's put it back into standard slope-intercept form. So I get y equals 3x minus 21. Okay, so that means that my inverse function, f1, all right, or f negative 1 of x equals 3x minus 21. Okay? And that's basically it. All right, pretty straightforward in terms of figuring out the inverse of the function. Let's take a look. I just want to prove something to you guys real quick. All right, I want to get some xy pairs from the original function, and I want to get some xy pairs from the inverse function and see how they correlate. All right, so let's say that we have x equals 0. All right, so if x equals 0, all right, what's our y value going to be, all right, in the original equation? All right, so if x equals 0, okay, y is going to equal 7, okay? So I'm going to have a pair, all right, a point at 0, 7. Good? All right, let's put in, let's find out one more value. Let's say what happens if x equals 3, right? So if x equals 3, okay, if I put that into my original equation, I'm going to get y equals 8, right? You can do the math. 1/3 times 3 is 1, plus 7 is 8, okay? And we're going to end up with a point at 3, 8. Now, what I want to do is I want to take these 2 points and shove them into, all right, my inverse function, all right, and see if I get those same values back. All right, so remember that the inverse, all right, when we were graphing, we took the x value and the y value and we switched them, okay? So that means that my inverse, okay, of 0, 7 should be, right, 7, 0, right? So when I put in, oh, my iPad's flipping out again. Hold on, there we go. All right, so when I put in a 7 into my inverse function, I should get back a 0, right? I switched the x and the y's between the first and the second, okay? And then in my, for my second point, I'm going to switch the x and the y, right? So where I had 3, 8, I'm now going to have 8, 3. So that means that if I put an 8 into my inverse function, I should get back a 3. All right, so let's see if that actually works. All right, so my expected, all right, so if I put in a 7, okay, I'm expecting to get back a 0, right? So what happens here? Well, 3 times, right, so f negative 1 of 7, all right, equals 3 times 7 minus 21. Well, 3 times 7 is 21. 21 minus 21, right, equals 0. So I get, right, 7, 0. So that one works. All right, let's try another point, okay? F of negative 1, all right, f negative 1 of 8, all right? What happens if that goes in, right? Okay, so we replace the x with an 8, right? So 3 times 8, okay, minus 21, right? So we get 24 minus 21, all right? And that's going to be 3. So I have another point in my inverse of 8, 3. And hey, look at that. That lines up with our expected inverse point. and 8 comma 3 lines up with our expected inverse point, which correspond back to our original function there and our original function there. All right, so that's basically what we're dealing with when we're dealing with inverse values, okay, inverse relations, inverse functions, okay? And remember that the point to all of this, all right, is relatively simple, right? The examples that I used at the beginning. If we have a Fahrenheit to Celsius conversion, well, if, you know, and I'm putting in a Fahrenheit value and getting back a Celsius value, all right, well, what happens if I want to do the opposite? If I want to put in Celsius and get back Fahrenheit, I can just figure out the inverse function and, you know, and be able to calculate in the reverse, okay? So that's all we have, all right, for inverse functions for today, all right? It's not that difficult, right? It doesn't seem, it sounds like a lot of words and it sounds like a lot of vocabulary, but ultimately we're just switching x's and y's. That's really all we're doing when it comes down to graphing, all right? And when it comes to figuring out the inverse function itself, we're switching the x and the y, and we are solving for y, and that's going to give us our inverse function. All right, that's it. I posted an assignment for you guys on Blackboard. Please take a look at that and finish it up. All right, that's your assignment for the snow day. All right, make sure that you get that done and turned in by the due date. Right, normal due dates. Okay, 8 o'clock the next morning. So we're all set. All right, guys. If you have any questions, drop me an email. If not, enjoy your snow day. Stay safe. All right, go build yourself a nice snowman. Make sure that you're helpful around the house, like shoveling driveways and stuff like that. All right, guys, this is Mr. Moscato signing off. Have a great day. Bye-bye.